let x y be a continuous bivariate random variable with the joint probability density function f x y x y. Suppose this is given. Now, how we can find the marginal? The marginal probability mass function, probability density function we want to find, because x and y are continuous random variable. So, we want to find probability density function. In case of discrete random variable, we already discussed that how to find the probability mass function. So, the marginal probability density function of x is given by, so you can remember that how we can find for probability mass function the marginal probability mass function from x, you take the sum of the other variable. So, here probability density function of x, the marginal probability density function of x is given by, so f x x. So, what is that? This is nothing but d d x of f x of x, d d x of f x of x. So, this is the probability density function. Now, how we can find this is basically d d x of f x x is nothing but, now if you marginal, how we can find, this is nothing but if you take f x y of x infinitive, then it is nothing but the marginal. So, but we cannot write this infinitive in this way. So, because we have to take the limit. So, here you can see that just it is represented these things, but it is actually basically it is nothing but the meaning is that you are taking the limit. So, just it is just a notation, we cannot just put the value which is notation, you take the limit and then you write that. So, first of all you find that what is f x x. So, f x x is nothing but limit x y goes to infinity f x y of x comma y, this is the f x x. Now f x x it is known to us. Suppose we want to find the differentiation of this. So, what is this? So, this is nothing but f x y limit y goes to infinity, probability that x less than equal to x, y less than equal to y. Now, if you want to represent this y goes to infinity, these things we want to represent by probability density function, it is nothing but minus infinity to x and then it is minus infinity to y. So, suppose this is the joint probability density function, suppose u v du dv. So, first you write these things like suppose it is we are doing integration with respect to v first. So, dv du. So, then if you take y goes to infinity means we are just we want to find this integration minus infinity to plus infinity f x y u v dv and then du. So, this is your f x x. Now, by definition of the integration by integral calculus, it is a function inside and we want to take the minus infinity to x and then this the integration with respect to u. So, now if you take the integration minus infinity to plus infinity with respect to v, this function does not have the any, it is a independent of v, it is only function of u, and then this is some function of u, you are taking the integration minus infinity to x, that is f x x. Now, what will be by integral calculus, this if you do the derivative, so this differentiation we can find f x x is nothing but d d x of f x x, this integration is minus infinity to plus infinity f of x y, this will be coming like f of x y, this u now it is becoming, because we are taking the limit minus infinity to plus x and then y. So, this is actually v, we took this dv. So, this is the f x y of v dv. So, this is minus infinity to plus infinity f x y of, now if you use this integral some of the rules, if you take the derivative of this function, it will be nothing but evaluated at x f x y x v dv minus infinity to plus infinity. Basically, what finally we found, so you can see that here also this similarly it is explained here. So, in this here f x x is what we found, this is this, whenever you are taking the derivative it is becoming f x y x eta d eta. So, that means just without go through in this complicacy, if you can understand how we found in the discrete case. So, discrete case we found f x y of suppose x I y j, if you take fixing x I, if you take the sum of the other variable, we found the marginal density function for the x is discrete case, whenever x is discrete case. Now, for continuous case, how we can find that? Continuous case f x x we will find. So, instead of sum we will take the integration of the joint density function x y with respect to the other variable. So, this is the whenever if x is continuous random variable. So, this is the marginal probability density function. If you take the integration of with respect to other variable, then we will find the marginal probability density function of x. Similarly, you can find the marginal probability density function of y is given by, this is f of y, this is nothing but minus infinity to plus infinity f x y of x y. So, in that case y fix y, particular values of y, we take sum here in the discrete case is sum for the continuous case integration of the other variable dx. So, then we will get the with respect to x we will do the integration. So, then we will get the marginal probability density function of y. So, this is the probability density function of y, here marginal probability density function of x we can find by this formula. So, next we will discuss. So, hope we have understood that, you have understood how whenever the joint probability density function is given, how we can find the marginal probability density function of x. Similarly, how we can find the marginal probability density function of y, we can we have understood that. So, now we will do some example also, so then it will be more clear. Now, we know that whenever x and y are independent, so if x and y are independent random variables, then this joint probability density function, cumulative distribution function is equal to f x x into f y y for all x y belongs to the real number. So, that we know that if x and y are independent random variables, then f x y of x y is equal to f x x into f y y for all x y belongs to the real number. Now, if we do the derivative d dx of f x y x y, then this is nothing but d dx of f x x. Note that it is independent of y, so x, so this is f x of f y of as it is f y y. Similarly, if you do the next again derivative with respect to y dx f x y, this is nothing but d dx of f x x. So, it is independent of x, so the derivative will be on f y y. So, now what is the left hand side? It is nothing but the joint probability density function. The right hand side, it is nothing but joint marginal probability density function. This is marginal probability density function of x and marginal probability density function of y. Hence, then this is true for all x y belongs to R. So, this is actually equivalent we are getting. So, for checking that the two random variables are independent or not, so there are many approaches now. One is that we can find their joint probability distribution function, and we can see that whether it can be as a product of their marginal probability density distribution function, cumulative distribution function. In case of continuous cases, we can also check that whether their joint probability density function can be represented as a the product of their marginal probability density function. So, x and so if x and hence we can say that x and y are independent random variable, independent continuous random variables if joint probability density function, it can be represented multiplication of their multiplication of their marginal probability density function for all xi belongs to R. So, if you can represent that their joint probability density function can be represented by their product of their marginal probability density function, then we say that x and y are independent random variables. So, these are the concept whenever they are continuous random variable, their cumulative distribution function, their joint probability density function, how to find the marginal probability density function from the joint probability density function, and then how to check that these two random variables are independent by checking the joint probability density function is equal to the product of their marginal probability density function for all x and y. So, now we can now discuss some examples. So, let us discuss this example. One example here it is given. Suppose a joint probability density function of a bivariate random variable xy is given by this. So, fxy of xy is equal to k into xy for 0 greater than x greater than 0 less than 1, y greater than 0 less than 1 and 0 otherwise, where k is actually a constant, k is a constant. Find the values of k, find a value of k, are x and y independent, find probability of x plus y less than 1. So, let us discuss this. So, the joint probability density function, the joint probability density function of a bivariate continuous random variable is given by fxy of xy, f of fxy of xy is equal to k of xy whenever 0 less than x less than 1 and y 0 less than y less than 1, this is equal to 0 otherwise. So, the joint probability density function of a bivariate continuous random variable is given by fxy of xy is equal to kxy 0 less than x less than 1. So, this is the, so now k is a constant where that means it is some real number. Now, we have to first find the k. So, this is find the value of k. So, how we can find the k? So, now we have to check the properties of the, so because it is a probability density function, joint probability density function, it should satisfy all the properties of a joint probability density function. Now, some of the properties are it should be greater than equal to 0. So, here k is a constant. So, x y between 0 to 1 and y between 0 to 1, this is actually positive value. So, k has to be positive value and 0 otherwise. So, k this will be greater than equal to 0 if k is positive value. Now, the integration over the region that should be is equal to 1. So, that will use this. So, minus infinity to plus infinity, minus infinity to plus infinity, fxy of xy dx dy should be equal to 1, that is the property. Now, it is equal to 0 outside this region 0 to 1 0 to 1. So, that is why this will be 0 plus 0 to 1 0 to 1 fxy xy in this region k of xy dx dy, this is equal to 1. Now, we have to do the integration. Now, first if you do the integration with respect to y with respect to x, this is nothing but x square by 2 0 to 1 and then dy, this is equal to 1, which implies k into x square by 2, the limit 1 by 2 minus 0 actually 1 by 2. So, this is nothing but k by 2 integration 0 to 1 y dy, this should be equal to 1, which implies now y is integration is k by 2 y square by 2 0 to 1, this should be equal to 1. Now, if you do the basically limit y is 0, y is 1 now 1 by 2 minus 0. So, this is nothing but k by 4 is equal to 1, which implies k is equal to 4. So, this value k should be is equal to 4. So, that it will be a probability density function. So, this is we found that this value should be 4. Next is that this is asked that whether x and y independent. So, that is why first we have to find the marginal. For independence, actually what is the definition? We have to show that f x y of x y, this is nothing but f x x into f y y for all x y belongs to the real number. So, to have this relationship true, we have to first find out what is f x z and f y y. So, that for to check this relationship, first we need to know. So, what is the marginal? The marginal, the marginal probability density function of x is given by marginal probability mass function f x x, because joint probability density function now we know. So, this is nothing but how we find minus infinity to y f x y x y, sorry, actually minus infinity to plus infinity, we have to integrate over y whole region dy. Now, this function actually, because if x is between 0 to 1, then this function is k x y. So, this is minus infinity to plus infinity, k is we found 4 x y dy, otherwise it is 0, otherwise 0, otherwise. So, then minus infinity to plus infinity 4 x y dy, you have to do the integration. So, let us do this integration here, minus infinity to plus infinity 4 x y, 4 x y. So, 4 x is constant here. So, this integration will be nothing but 4 x into because fixing x some value of x, y is y square by 2. So, yeah, 1 minute, it is okay, it is not, yeah, minus infinity to plus infinity 4 x y, no, this value whenever y is 0 to 1, then only it is 4 x y, otherwise it is 0. X between 0 to 1, not only that, y also between 0 to 1. So, that is why it is, otherwise this integration will be 0 plus something. So, that is why this is 4 x into y square by 2, and this limit is nothing but 0 to 1. So, this value is 2 and 2 cancel, y square is 1, 1 minus 0, 1 by 2. So, 2 cancel, 4 x into 1 by 2, 2 cancel, this is nothing but 2 x. So, finally, what we got? This is nothing but, this is equal to 2 x whenever x between 0 to 1, this is equal to 0, this is equal to 0, otherwise. So, this is the marginal probability density function. So, if the computation is correct, you can check, because it has to be a probability density function, integration over 0 to 1, that should be equal to 1. So, you can see that x square by 2, 2 by 2 cancel, and in a limit 0 to 1, this is equal to 1. So, that is why this is a probability density function. Now, similarly, the marginal probability density function, the marginal probability density function of y is given by f of y y, it is nothing but minus infinity to plus infinity f x y x y. Now, we will do the integration with respect to x. So, similarly, we will do that, you can understand now. So, this will be nothing but 0 to 1 4 x y with respect to x whenever y between 0 to 1, otherwise it is 0, otherwise. So, then after doing this integration, similarly it is by symmetry actually very same. So, 2 y whenever 0 less than y less than 1, it is 0, otherwise. Now, we can see that what we observe that if x is between 0 and 1 and y is between 0 and 1, f x y is x y, this is nothing but 4 x y, this is nothing but 2 x into 2 y, which is f x x into f y y. For any other region, if 0 less than, if 0 outside this does not belongs to this interval, or y does not belongs to this interval, one of the cases f x y is equal to 0, which is equal to f x x into f y y. So, basically f x y will be 0 if one of the x and y will be outside this interval or both, and the right hand side, if x does not belongs to 0 1, then f x s will be 0, the product will be 0, and y does not belongs to 0 1, then f y y will be 0 and the product will be 0. If both are outside the region, then this will both are 0. So, that is why if this or this, then so hence what we found that f x y of x y is equal to f x x into f y y for all x y belongs to R, or we can say that this vector belongs to R2. So, hence x and by definition or from the properties of the independence, hence x and y are independent random variables. X and y are independent random variables. So, that we found finally, and next question is that find probability of x plus y less than 1. So, how we can find, we can compute this kind of questions. Find probability of x plus y less than 1. How we can find this probability? So, now let us graphically we represent this first of all, so that it will be helpful to understand. This is our 0 to 1, this is 0 to 1, this is the region actually the density function exists 0 to 1, 0 to 1, this is 0 1, this is 1 0, this is 1 1. So, this density function is non-zero inside this region. Now, it is asked the question x plus y less than 1. So, what is the line x plus y is equal to 1? So, x plus y is equal to 1 will be this line will be x plus y is equal to 1. Now, less than 1 means what is the probability of this function of this random joint random variable, it is taking the value inside this region. So, if you want to do, so we have to find this probability is integration over the region x plus y should be less than 1 f x of y x y dx dy. Now, to finding this, because this is not 4xy for all these region, only this square intersection this region it will be 4xy, that we have to find out. So, how we will do that? The region will be, see that whenever x is or y is between 0 and 1, any fixing any value y, then x not going 1, it is up to this value. What is this value? This value is nothing but x plus y is equal to 1, this line for a fixing 1, this value is y, and this value any value y, and then sorry this x coordinate will be 1 minus x comma y. So, sorry 1 minus y actually comma y. So, this point actually x coordinate will be, so that means this integration will be up to 0 to actually maximum it can go 1 minus y, and then this is 4xy and then dx, and the limit of y will be 0 to 1. So, this will be nothing but 0 to 1, 0 to 1 minus y, 4xy dx and then dy. So, this is we have to do the integration now 0 to 1 and integration 0 to 1 minus y. So, this is first 4y is constant here, this is x square by 2, this is the integration, and this is 0 to 1 minus y first limit, and then this is dy. So, then what we will get, x 2 and 2 cancel 2y. So, 2 0 to 1, then this is y into 1 minus of y. So, x square whole square actually 1 minus y whole square, x square by 2 1 minus y whole square minus 0. So, this is y square into dy. So, then we have to do this integration, this is nothing but 0 to 1 y into 1 minus y square 1 minus 2y plus y square then dy. So, finally, what we are getting 2 into 0 to 1 y minus 2y square plus y cube dy. Then we have to do this final integration, this is nothing but y is y square by 2, this is 0 to 1 minus 2 y cube by 3, this is also 0 to 1 plus y to the power 4 by 4, this is 0 to 1. So, then what we are getting finally, so this is equal to 2 into, so this is just a numerical computation we have to do 2 into 1 by 2 minus 2 by 3 plus 1 by 4. So, let us do here the final. So, which is equal to 2 into 1 by 2 minus 2 by 3 plus 1 by 4 plus 1 by 4. So, this is equal to 2 into this is 12. So, then 6 minus 8 plus 3. So, then this is 6 plus 9 minus 8 1 by 12, 2 by 12, this is nothing but 1 by 6. So, if this computation are correct, so then this probability is nothing but 1 by 6. So, this is the answer, this should be the answer. Please check that these computations are correct, otherwise you see that whether this answer is coming the same answer, you can go through it again. Next we will discuss another numerical example. I hope this numerical example you have understood how this joint probability density function, how to find this constant k, and then how to find for checking x and y are independent, we first have to find the marginal probability density function of x and y, and then we check that it is independent, and then how we can compute it the probability that x plus y is less than 1.